Alright class, this video is on composition of functions. Like we said in class, composition of functions are a function inside of another function. So right here we have two functions. We have f of x, which is 2x plus 6, and g of x, which is 7x. So an example of a composition is something like this. This here we say as f of g of x. I should actually probably write this. What this means is that the function g is inside the function f. How we actually compute this is basically the outside function, this bigger one, f. What I like to do is I like to write this, which is 2x plus 6. The thing is that instead of writing x, I'm going to put a set of parentheses. Because what goes inside that set of parentheses is our function of g. Okay, instead of putting g, I'm just going to put 7x. Noticing that we have f of something, that is what goes in for our variable of x. And in this case, we can simplify. I'm going to use the black marker for this. This would then be, let's say, 2 times 7, which is 14. 14x, then we have this positive 6, and that's it. So the composition of f of g of x is 14x plus 6. What I like to do is I like to go the other way as well and compute g of, in the opposite sense, we're going to put f of x. Alright, so this is a little bit reversed. So again, now in this sense, we have g is our outside function. We're going to write 7x. So I'll put 7, but instead of writing x, remember we're going to put a set of parentheses. So I'm not writing x. What we're replacing that with is 2x plus 6. So I'm going to go ahead and write that. So this is a little bit different than the first one. Here, we're actually distributing. We have 7 times 2x, which is 14x, and 7 times 6, which is a 42. So noticing which function you put into the other or even the order can affect what output you receive of this composition. Okay, the next example I'm going to explain is how to evaluate a composition. So instead of here, we're actually going to have inputs, numerical inputs. So at this point, now we have two functions. I've given you different functions for this example. We have f of x equal to 3x plus 1 and g of x equal to x squared. Now we're actually going to compute a composition, but in this sense, now we have a numerical input. When you have something that's set up this way, what you like to do is actually tackle the inside part of it first and then work your way out. So noticing that we have f of 2, go ahead and simplify f of 2. So what I'm going to do that right here. So instead of f of x, we have f of 2 equal to, and we'll have 3. Instead of x, you'll have an input of 2. I'm going to write that in black. Looks like this. Simplifying this, we'll have 3 times 2, which is 6, and then 6 plus 1, which is 7. So f of 2 is equal to 7. So instead of this part here, instead of f of, or g of f of 2, f of 2 is 7. So for our step 2 here, we're going to compute that, g of 7. Okay, and g of 7 instead of g of x, we're going to compute g of 7. So in this sense, we have x squared, we're going to have 7 squared. So, and it's simply here, you just square this will be 49. And that is your end product. So we can say that what we originally started with, g of f of 2 is, after doing these compositions, is 49. All right, this has been a composition of functions.